Om Sri Sai Ram. My humble salutations to my beloved Bhagwan, respected elders, and my dear students. Once again, hearty welcome to Numerical Analysis class. We are going to continue with unit number 2, Solutions of Algebraic and Transcendental Equations. So today we are going to discuss about another method in solving these solutions by iterative method. So part 3 we are going to continue. Explain the fixed point method or fixed point iteration method. పునరుక్తి పద్ధతిని గురించి వివరించండి. Fixed point method or fixed point iteration method. So consider the equation f of x is equal to 0 whose roots are to be determined. The equation f of x is equal to 0 can be expressed as x is equal to phi of x. Putting x is equal to x naught in the right hand side of x is equal to phi of x, we get the first approximation x1 is equal to phi at x naught. The successive approximations are then given by x2 is equal to phi at x1, x3 is equal to phi at x2, x4 is equal to phi at x3, and further nth approximation xn is given by the value of the function phi at x n minus 1, n minus 1th approximation, where the sequence of approximations x1, x2, etc. xn continuous always converges to the root of the function x is equal to phi of x. And it can be shown that if the modulus of the derivative is less than 1, when x is sufficiently close to the exact value of c of the root, xn converges to c as n tends to infinity. ఇది చాలా సులభమైనటువంటి పద్ధతి, ఈ పునరుక్తి పద్ధతి. f of x is equal to 0 అనే సమీకరణాన్ని యొక్క మూలాలను ఈ పద్ధతి ద్వారా మనం కనుక్కోవడానికి అవకాశం ఉంది. ఇచ్చినటువంటి ఈక్వేషన్ f of x is equal to 0ను x is equal to phi of x రూపంలో మనము రాసుకోవాలి. x బదులుగా x నాట్ అన్నది కుడివైపు సమీకరణంలో ప్రతిక్షేపించినప్పుడు x is equal to phi of x యొక్క ప్రథమ ఉజ్జాయింపు విలువ x1 equal to phi at x నాట్ అనేది మనకు లభిస్తుంది. ఇదే విధంగా ఇదే పరంపరలో రెండవ ఉజ్జాయింపు x2 is equal to phi at x1 అని, మూడవ ఉజ్జాయింపు x3 is equal to phi at x2 అని, నాలుగవ ఉజ్జాయింపు x4 equal to phi at x3 అని, అలాగే ఎన్నవ ఉజ్జాయింపు phi at xn మైనస్ 1గా మనము లభ్యమవుతుంది. సో ఈ విధమైనటువంటి అనుక్రమాలు x1, x2, ఎక్సెట్రా xn విలువలు వరుసగా అవి అభిసరిస్తుంది. ఎప్పుడు అంటే మాడ్యులస్ ఆఫ్ phi of x ఒకటి కన్నా చిన్నదైనప్పుడు, phi dash x ఒకటి కన్నా చిన్నదైనప్పుడు x అన్నది cకి దగ్గరగా సమీపిస్తుంది యాజ్ n tends to infinity. అప్పుడు c అన్నది f of x is equal to 0 అనే సమీకరణం యొక్క సాధన లేదా మూలము అని అంటారు. Now we will continue with this some problems. Locate the root of the equation x square plus x minus 2 equal to 0 using the fixed point method. పునరుక్తి పద్ధతిని ఉపయోగించి x square plus x minus 2 equal to 0 సమీకరణానికి సాధించండి. So x square plus x minus 2 is equal to 0 can be written as x into x plus 1 that is equal to 2. Therefore x is equal to 2 by x plus 1. We call that as phi at x. Now phi at x is equal to nothing but 2 times of x plus 1 whole inverse. Therefore phi dash x is equal to minus 2 into x plus 1 whole to the power of minus 2. Therefore modulus of phi dash at 1 is nothing but modulus of minus 2 by 1 plus 1 whole square, that is 2 square. That becomes 1 by 2, which is less than 1. Therefore by fixed point method we can consider the first approximation is given by x1 is equal to 2 by 1 plus 1, that is equal to 1. Therefore 1 root is 1. So ఇచ్చినటువంటి సమీకరణ x square plus x minus 2 equal to 0ను x into x plus 1 equal to 2గా రాయవచ్చు. దీని నుండి x is equal to 2 by x plus 1గా మారుతుంది. ఈ విధంగా రాసినటువంటి రైట్ హ్యాండ్ సైడ్ను 2 by x plus 1ను phi of xగా మనము తీసుకుంటాం. సో phi of xని ఈ విధంగా కూడా రాయవచ్చు, 2 into x plus 1 whole inverse. Therefore phi dash x ఏమవుతుంది, దీని యొక్క అవకలజము minus 2 into x plus 1 whole to the power of minus 2 అవుతుంది. ఇప్పుడు రెండు వైపులా మాడ్యులస్ తీసుకుంటే మాడ్యులస్ ఆఫ్ phi dash at 1 equal to minus 2 by 2 square modulus, that is nothing but 1 by 2. ఈ విలువ 1 కన్నా చిన్నది కనుక పునరుక్తి పద్ధతిని అనుసరించి ఎక్స్ యొక్క పై సమీకరణం యొక్క మొదటి ఉజ్జాయింపు x1 ఈక్వల్ టు 2 డివైడెడ్ బై 1 ప్లస్ 1 దట్ ఈస్ ఈక్వల్ టు 1. కనుక ఒక రూటు ఇచ్చినటువంటి సమీకరణానికి రూటు 1 అన్నది ఏర్పడుతుంది. నెక్స్ట్, find the root of x cube plus x minus 1 equal to 0 by iteration method given that the root lies near 1. So x cube plus x is minus 1 equal to 0 సమీకరణాన్ని పునరుక్తి పద్ధతిని ఉపయోగించి దీని యొక్క మూలము 1కి దగ్గరగా ఉన్నదని నిరూపించండి. So the given equation is given by x cube plus x minus 1 equal to 0. That can be written as x into x square plus 1 equal to 1. Therefore, x is equal to 1 by x square plus 1. That can be treated as phi of x. Now, what is phi dash x? That is nothing but minus 2x divided by 1 plus x square whole to the power of minus 2. Therefore, modulus of phi dash at 1 equal to minus 2 into 1 divided by 1 plus 1 square, that is 2 whole square. That becomes 1 by 2 actually. So which is less than 1. So by iteration method, we can show that the first approximation x not equal to 1. Here it is a print mistake, x 2 to the power of 2 square only, that's all. Okay, because we are bringing it down. Okay. Now the first approximation is given by x1 is equal to 5 at x naught. We are taking 1 by 1 plus 1 square, that is equal to 1 by 2, that is equal to 0.5. The second approximation x2 is given by 5 at x1, that is 1 by 1 plus x square, that is 0.5 whole square. So that becomes equal to 0.8. The third approximation x3 is nothing but 5 at x2 equal to 1 by 1 plus 0.8 whole square, that is equal to 0.61. సో ఇక్కడ ఇచ్చినటువంటి సమీకరణం x క్యూబ్ ప్లస్ x మైనస్ 1 ఈక్వల్ టు 0గా మారినది కాబట్టి దీన్ని ఎలా రాసుకోవచ్చు? x ఇంటూ ఎక్స్ స్క్వేర్ ప్లస్ 1 ఈక్వల్ టు 1గా రాయవచ్చు. దీని నుండి 1 ఈజ్ ఈక్వల్ x ఈజ్ ఈక్వల్ టు 1 by 1 ప్లస్ x స్క్వేర్ అన్నది ఏర్పడుతుంది. సో ద గివెన్ ఈక్వేషన్ x అన్నది ఇచ్చినటువంటి సమీకరణాన్ని x ఈజ్ ఈక్వల్ టు 5 ఆఫ్ xగా రాయవచ్చు. ఇక్కడ 5 ఆఫ్ x విలువ 1 by 1 ప్లస్ x స్క్వేర్గా మారినది కనుక దీని యొక్క అవకలనం ఏమవుతుంది? 5 dash x ఈజ్ ఈక్వల్ టు minus 2x into 1 plus x square whole to the power of minus 2 అయింది. సో ఇప్పుడు ఈ 5 dash of 1లో 1 పెట్టినప్పుడు the value of the function at 1 is given by minus 2 by 2 square. If a print mistake 2 square it should be. That becomes equal to 1 by 2. దీని విలువ 1 కన్నా చిన్నది కనుక మొదటి ఉజ్జాయింపు x నాట్ is equal to మనం 1 అనేసి అనుకున్నప్పుడు శూన్య ఉజ్జాయింపు 1 అనుకుంటే ప్రథమ ఉజ్జాయింపు x1 ఈక్వల్ టు 5 at x నాట్ అవుతుంది కనుక 1 by 1 ప్లస్ x స్క్వేర్ x నాట్ స్క్వేర్ అంటే 1 స్క్వేర్, దట్ ఈస్ ఈక్వల్ టు 1 by 2 0.5. అలాగే రెండవ ఉజ్జాయింపు x2 ఈజ్ ఈక్వల్ టు పై సమీకరణంలో x1 ప్రతిక్షేపించాలి x బదులుగా. ఇప్పుడు x1 ఎంత? 0.5 కనుక 1 by 1 ప్లస్ x1 స్క్వేర్, దట్ ఈస్ 0.5 హోల్ స్క్వేర్. దీన్ని ఫర్దర్ సింప్లిఫై చేస్తే 0.8 అని వస్తుంది. అదేవిధంగా మూడవ ఉజ్జాయింపు విలువ x3 ఈక్వల్ టు 5 at x2 ఈక్వల్ టు 1 by 1 ప్లస్ 0.8 స్క్వేర్, దట్ ఈస్ ఈక్వల్ టు 0.61 అన్నది ఏర్పడుతుంది. ఇదే విధంగా మనము కంటిన్యూ చేద్దాం. ఫోర్త్ అప్రాక్సిమేషన్ ఈస్ గివెన్ బై 1 by 1 ప్లస్ 0.61 whole square. So on further simplification that becomes 0.73. The fifth approximation is 5 at x4, that is 1 by 1 plus 0.73 whole square, that becomes 0.65. Similarly, sixth approximation is 5 at x5, that is equal to 1 by 1 plus 0.65 whole square, that is equal to 0.7. Similarly, x7 is equal to, the seventh approximation is given by 5 at x6, that is 1 by 1 plus 0.7 whole square, that is equal to 0.67. x8 equal to 5 at x7, that is 1 by 1 plus 0.67 whole square, that is equal to 0.69. x9 is equal to 5 at x8 equal to 1 by 1 plus 0.69 whole square, that is equal to 0.68. Similarly, x10 is equal to 5 at x9, that is equal to 1 by 1 plus 0.68 whole square, that is equal to 0.68. Therefore, the root of the given equation is, finally, we have seen the two approximations are getting the same value. So we get this one. I hope this is clear. Okay, next, find the real root of the equation x cube plus x square minus 1 equal to 0 by iteration method. This is also the same. So here we are having, by taking x square common, this becomes x square into x plus 1 equal to 1. Therefore, x square is equal to 1 by x plus 1. Therefore, x is equal to 1 by x plus 1 whole to the power of 1 by 2. So, phi of x is equal to this. Now, what is phi dash x? Minus 1 by 2 into x plus 1 whole to the power of 3 by 2. Now, at x is equal to 1, phi dash x becomes equal to phi dash of 1 equal to 1 minus 1 by 2 into 2 whole to the power of 3 by 2, that is less than 1. So by iteration method can be applied. So the first approximation is given by x1 is equal to phi at x naught, that is 1 by square root of 1 plus 1, that is equal to 1 by root 2, that is equal to 0.7071. Similarly, the second approximation is given by x2 is equal to phi at x1, that is once again 1 by square root of 1 plus 0.7071. So that becomes 0.7654. The third approximation is given by x cubed is equal x3 equal to phi at x1, sorry, phi at x2, that is 1 by square root of 1 plus 0.7654, that is equal to 0.7526. Here it is a typo error. Okay. Next approximation, the fourth approximation is given by phi at x3. Once again, that is nothing but 1 by square root of 1 plus 0.7526. That becomes 0.7554. Now, fifth approximation x5 is given by phi at x4. That is nothing but 1 by square root of 1 plus 0.7554. That becomes 0.7548. Similarly, the sixth approximation is phi at x5. That is 1 by square root of 1 plus 0.7548. That becomes equal to 0.7549. Seventh approximation is nothing but given by phi at x6. 1 by square root of 1 plus 0.7549. That becomes 0.7549. Both the approximations are the same, so we are going to stop here. The root of the given equation is given by 0.7549. I hope this is clear. Similarly, on similar lines, find the root of the equation 2x is equal to cos x plus 3, correct to 3 decimal places by iteration method. 2x is equal to cos x plus 3 అన్నది మూడు దశాంశ స్థానాలకు సవరించి పునరుక్తి పద్ధతి ద్వారా ఈ సమీకరణం యొక్క సాధనను కనుగొనండి. So 2x is equal to cos x plus 3, therefore x is equal to 1 by 2 into cos x plus 3. So we call that as the right hand side as phi of x. So what is phi of x? 1 by 2 into cos x plus 3. Now what is phi dash x? 1 by 2 into derivative of cos minus sin x. And modulus of phi dash x is equal to 1 by 2 into modulus of sin x. And the value of sin x is always less than 1. So it is 1 by 2, that is always less than 1. So by iteration method can be applied. Let the initial approximation be x naught is equal to pi by 2. So x1 is equal to phi at x naught is nothing but 1 by 2 into cos x naught plus 3. 1 by 2 into cos x naught pi by 2. Cos 90, 0. So 3 by 2, that is 1.5. Now the second approximation x2 is given by phi at x1, that is 1 by 2 into cos x1 plus 3. That is half into cos 1.5 plus 3. And for the simplification, we can show that this is equal to 1.535. The third approximation x3 is given by phi at x2. 1 by 2 times cos x2 plus 3. 1 by 2 into cos of 1.535 plus 3. That is equal to 1.518. Next, the fourth approximation x4 is given by phi at x3 equal to 1 by 2 times of cos x3 plus 3, that is equal to 1 by 2 into cos of 1.518 plus 3, that becomes equal to 1.526. Next, the fifth approximation is given by phi at x4, 1 by 2 into cos x4 plus 3, 1 by 2 into cos of 1.526 plus 3, that is equal to 1.522. Sixth approximation is given by phi at x5, 1 by 2 into cos x5 plus 3, that is equal to 1 by 2 into cos of 1.522 plus 3. So we can see that that value is nothing but we get 1.524. So the seventh approximation is given by phi at x6, 1 by 2 times of cos x6 plus 3, 1 by 2 into cos of 1.524 plus 3, that is equal to 1.523. And further, the eighth approximation is given by phi at x7, 1 by 2 cos x7 plus 3, that is 1 by 2 times cos of 1.523 plus 3, that is equal to 1.524. Therefore, the approximation root is given by 1.524. I hope this is clear to one and all. Thank you for watching. Okay. So on similar lines, we are going to consider another problem. Given, find the real root of the equation cos x is equal to 3x minus 1, correcting to 3 decimal places by iteration method. సో ఇంతకుముందు మాదిరినే ఇక్కడ కూడా మనం తీసుకోవాలా. సో 3x x is equal to, we can see x is equal to that becomes actually 1 by 3 times of cos x plus 1, and modulus we can see that value is going to be less than 1, we can show here, that is missing. Anyway, the initial approximation x naught is equal to 0. If you consider x1 is equal to 5 at x naught, 1 by 3 into cos 0 plus 1, that becomes 0.667, and x2 becomes 5 at x1, 1 by 3 into cos of 0.667 plus 1, that is equal to 0.5953. Similarly, the third approximation we can calculate. Proceeding on similar lines, we can easily see that up to 3 decimals we are having the same number of digits. So it is given by, finally the root is given by 0.607. Okay. So thank you very much for watching this video.